Okay, here's our lesson 5.1, linear functions. We've already talked about functions, and a lot of this lesson should just be a review for you, either from what we've already done this year or maybe even what you learned in 8th grade. So the first thing we want to do is talk about what does linear mean versus something that's nonlinear. So if you think about the word linear, it has the word line in it. And it's pretty much exactly what you think it is. The graph of a linear function is going to just be a straight line. That line can go any direction. It can go up or down or across, right? Any of those things are linear functions, but the note that you're going to want to take here is that a linear function is a straight line. And then obviously the opposite of being straight, nonlinear, would be anything that is curved even a little bit. So even though what we see right here is a function, so this is a function, because it's going to pass my vertical line test, right? If I draw my vertical line, it's only going to touch one time. It is a function, but it is not linear because it's not a straight line. Graphs are really easy to check. When we look at a table to determine if it's linear or not, so an example of a table might be something like 1, 3, 5, 7, and on the other side maybe we have 3, 6, 9, 12. This is something that's linear because notice on the y side we're going up by 3 each time, and on the x side we are increasing by 2 each time. Linear has a constant rate of change. That just means that it's changing the same on both sides with each increment. Nonlinear doesn't have a constant rate of change. So one of the examples, a table that you've already done before, is x squared. So if we have negative 2, negative 1, 0, 1, 2, here my table, my y values might look like 4, 1, 0, 1, and 4. Notice that on the x, it is constant. The x is going up by 1 every time. But on the y, I'm going down 3, down 1, and then I turn around and I start increasing. This is an example of something that is not linear because this is a non-constant rate of change. So we can just say it is not constant. It's a not constant rate, I'm abbreviating, rate of change. And the equations, now this is where you want to take specific notes because you're going to have to be able to identify linear versus nonlinear from an equation. Linear equations in the standard form, so it's important that you know that this is standard form for a linear equation, is ax plus by equals c. And there are a few rules here that we need to know. First of all, you need to know that all of these right here are integers. And remember, integers are like my counting numbers, positives and negatives. So negative 3, negative 1, 0, 1, 2, 3, right? All of those are integers. Standard form, also know that there are no exponents on the x and y. There are no fractions anywhere. This is standard form. Nonlinear equations, there's a few different things that can make it nonlinear. The first thing is if you have any point where you have exponents. So like y equals x squared is nonlinear because of the exponents. Exponents are when you are multiplying something by itself. So another issue is if you're multiplying variables. So if you have like 4xy equals 8, that's also not linear because you're multiplying variables. And then the last one here, the last nonlinear that you might see is something where you have, let's say, 2 over x plus 3 equals y. The issue here is that you've got this x on the bottom. And I'm not going to go into a ton of detail. Just know that x cannot be on the bottom, and it's really going to be the same issue that you had before if you try to fix it. So you cannot have x on the bottom if you want it to be linear. Okay. So let's look at an example where we're graphing linear. What I'm going to show you today, I'm just going to be honest, I do not think that this is the easiest way to work these problems, but it's important that you understand this method, and this is one that we struggled with a few chapters ago, so we are going to spend a moment on it today. So graphing linear, we're going to do that using a table. So this is the equation that they've given us, and I'm going to start by making myself a table of values. X, remember in the middle is where my rule or my equation goes. So I'm just going to copy my rule or equation there, negative 4x plus y equals 11. And on the far side, I'm not going to call the far side y, I'm going to call the far side solutions. So solutions are going to be written x comma y. And there are two things that you need to make a note of. Solutions are points on the graph, and they are values that make the equation, so they make the equation true. Which means if I plugged them into my equation, they would give me a true statement. So on this one, in your book, I'm not sure if they're going to give you values or not, so I'm just going to start actually by just picking some easy values, and I'm just going to say negative 2, negative 1, 0, and 1. Those are the values that I want to use this time. So I'm going to erase that to give myself room. So negative 2, this is an x value, so I'm going to plug into the x spot. Plus y equals 11. And now I need to take a minute to solve. So if I multiply, that gives me 8 plus y equals 11. I've got to subtract 8 so I can get y by itself. So I know y is going to equal 3. So the solution I want to write here is the ordered pair, negative 2, 3. This side of your table is so important. If you don't put that, I'm going to be counting off because that is something you very, very much need to know, and you need to start connecting that has to do with the graph and with the equation. All right, let's try our next one. So negative 1. If you think you can do this, pause and try it on your own, and then come back and just check and make sure you got it right. So this is 4 plus y equals 11, which means y is going, if I subtract 4 from both sides, that's going to give me 7. Negative 1, 7. Do the same thing with 0. Negative 4 times 0 plus y. Anything times 0 is 0. So this one's actually really easy. That's just y equals 11. And then our last one is positive 1. So I'm going to have negative 4 times 1 plus y. This is going to give me negative 4. And to get rid of that negative 4, I'm going to add it. So y is going to equal 15. So I'm going to have 1, 15. This is another reason I wanted you to write the table, because I want you to check right now. Pay attention to this table. You should notice the x's are increasing by 1 every time. That's linear. And then let's check the other side to make sure the whole thing is I am adding 4 each time. So because of that, I know my table is done correctly. All right, that's the first way that you're going to check. The second way that you can check to make sure everything is done correctly is we can graph. So I'm going to take a second. If you would pause, and I want you to draw yourself your own graph and just try to plot these points really quickly. And as you can see, I plotted those 4 different points. I kind of ran into my words, and it's not going to be perfect unless you're obviously doing it on graph paper, but you should notice that what you're given here is a set of points that is roughly linear. That is a very straight line. If you had graph paper, you would be able to recognize that that is straight. Notice that now that I've connected it, it's continuous. Remember these words. Now that I've connected it, it's continuous. But before, when we had the separate points, so the separate points, we called that discrete. And that's going to come into play more when we start talking about word problems. So that's continuous versus discrete. Just remember that. Okay, last problem is actually a word problem. We're going to spend plenty of time on these tomorrow. So take a second, pause, and I want you to read the problem just to make sense of it. Okay, so in this problem, you should notice they go ahead and give us a function. They tell us what everything stands for. So x is the number of umbrellas. Notice that they've put that on the x-axis for us already. 6 is the cost, or how much he's paying for each umbrella, or how much he pays to the mall owner, rather. So they want us to do a few things. The first thing they want us to do is to graph the function, and then the second thing they want us to do is give the domain and range. So they actually give us the domain. Remember, domain are my x values. So we want to graph this. So we're going to make our little table. And this one, hopefully you recognize, is a little easier. My function rule is 6x. F of x is the same kind of idea as y. I'll write f of x for us. So f of x equals 6x. And this far place is going to be solutions. So they go ahead and give us some values they want us to try. So they're saying to try 0, 1, 2, 3, 4. If you don't see, I'm getting that from this x-axis down here. Those are the numbers they give me to try. So I'm just going to plug that in. F of 0 equals 6 times 0, which is 0. So my ordered pair is 0, 0. 1, f of 1 is 6 times 1, which is going to give me 6. So I do 1 comma 6. If we finish this table out, so I want you to pause and finish the table. And now I want you to check that we have the same solutions. So 2, 12, 3, 18, and 4, 24. That's what we should have gotten. Again, you can check your table by verifying that the change here, that's kind of hard to see, I'm writing in yellow, verify that the change on this y side is constant every time. It's the same amount, and the same for the x side. Now I'm just going to plot and hope that I get a straight line, which I should if I plot everything correctly. So 0, 0, 1, 6, 2, 12, 3, 18, 4, 24. This is straight. In this instance, it does not make sense to connect the lines because you can't sell part of an umbrella. So we want to keep this one discrete. And then they want us to name domain and range. So here, my domain are my x values, so 0, 1, 2, 3, 4. And my range are the y values that I just calculated. So I can even look. You could look up here in this y part of your table. My y values are going to be 0, 6, 12, 18, 24. Done with that problem. All right, this is the point where you just want to check and make sure that you've taken notes well. You should be able to answer all 3 of these questions within your notes. So if you don't have answers, if some of this is not somehow written in your notes, then you need to go back and rewatch the video. We will very quickly talk about these at the beginning of class, do some examples, and then start working some problems for today. Hope that this helped.